Hi, and welcome back. So last time we had talked through some of the materials related to manipulating strings and cleaning up information that were stored in character information using free text character information. And we talked about some use cases. So I had made the statement that unlike the dplyr package where you're going to be using those combinations of dplyr functions just throughout your entire data analysis and data cleaning workflow. Stringer can be a little bit hit or miss. Sometimes you'll have very, very little to do with the stringer package, but then other times you'll be doing nothing but just hours and hours of string manipulation. It sort of depends on how the data were collected at the start. And it is my opinion that if the data were collected really well to begin with, then you shouldn't need to use the stringer package very much. However, a lot of times whenever we're doing secondary data analysis, we don't have a choice. We just get the data that we get. And so it's one of those things where Stringer is very useful and very, very important when you need it, but sometimes you don't need it very much. But regardless, we talked about how to work with character string information, and we kind of ended off that lesson talking about how the Stringer package doesn't work on rectangular data itself. It works on the column of the character information inside the rectangular data. So you have to use the subsetting rules to get at the column, and we usually pair the Stringer functions with the mutate command to make sure that we're performing operations on the contents of the columns of this rectangular data rather than trying to work on the rectangular data itself. Okay, so that's a recap of kind of what we went over with the Stringer lesson, all about character strings. And what we're going to do over these next few videos, so this is lesson 11, this is all about control flow and functions. Um, so the purpose of this is kind of this lesson or these set of lessons here, or lesson 11, if you will, these set of videos. This is going to be one of the other things that makes this material somewhat challenging to learn. Okay. So I gave an introduction when we had talked about atomic vectors and non-atomic vectors, these lessons down here, that a lot of the original name for the course was Advanced R because this material came from the Advanced R textbook. A lot of this material in lesson 11 also comes from the Advanced R textbook. So this is less directly related to data science and more related to just programming in general. Okay. Um, some of you may find this lesson a little bit more challenging, and that's okay. It's this lesson is one of those kind of like high risk, high reward type lessons. If you don't get it, like if some of this material is challenging for you, then that's fine. It just means that whenever you're doing data analysis and data science in practice, you're going to have less opportunity to, or you're going to find that solving some of the problems that you need to solve are going to be a little bit more challenging, simply because you don't have the ability to create your own functions. But for those of you who can pick up the material in this lesson and start to use it well, it will open up just so many doors of opportunity for you. So I'm gonna give this one last piece of introductory advice. Don't give up on this lesson. This lesson is challenging for everybody the first time that they go through it. Talk to your partners, talk to the other people in the class, talk to me, talk to the TAs for the class. Try to really wrap your head around what's going on in this material and give it your best shot. Okay. All right, so without further ado, we're going to talk about control flow in these videos. We're going to talk about creating functions. We're going to talk about best practices for writing functions, and we'll also talk about something called function scoping. We're obviously not going to get through all of this in one video, but we'll get through kind of as much as we can. So as I mentioned before, this lesson and then also the next lesson on iteration with PER, they can be pretty difficult. So don't give up on the material just because it didn't make intuitive sense to you the first time that you tried to work through this. It's high risk, high reward. Try to get through this material. Try to understand it as much as possible. It's a little bit more complex, but I think that you can do it. So as a review, I've used the phrase expression before. The most recent time I think that we talked about an expression was working with the case when function. So in the case when function, you had a tilde in the middle, and you had a logical check on one side and some output on the other side of the tilde. And both of those are expressions. Really, when we're talking about expressions, we're just going to talk about a single like compact representation of a code of a code action, if you will. And it's just that we need to get a little bit more theoretical when we're talking about what exactly is happening with the code. So we might need to use this phrase expression. So let's dive in and let's talk about control flow. Control flow is what makes a computer language an actual computer language. Okay. So under the hood, everything that we have done in R up to this point, whether we've worked in writing YAML headers or if we've worked in Quarto, if we've worked in R, be it dplyr or ggplot or anything else, everything is built under the hood, like deep in the internals of the computer, on some very simple statements. And those simple statements are known as the control flow statements. The simple statements are if and else, for, and while and break. So these 5 statements over here. Basically, if you have access to these 5 statements, and it's even a little bit simpler than that because you can break down these 5 statements into a couple of other smaller substatements, if you will. But let's just say for the sake of argument, if you have access to these 5 statements, you could rewrite any computer language and therefore rebuild any application on your cell phone, on your computer, heck, your smart TV, like anything that runs computer code at the most basic level is going to be running computer code with these 5 statements: the if and else, the for, the while, and the break. And I guess it would make sense if I say if else together, while and break together, and then a for loop over here, just so that you kind of get the pairings and so forth. Live long and prosper. So what we've done so far in this semester, and we're on lesson 11, and we haven't really talked so much about how your computer actually does the things that it does. The control flow section is how we start interacting with these more fundamental forces of computation, if you will, and algorithms. And so let's dive in. Let's talk about if and else. We may get through the for loop in this video, but it'll probably by the time we finish talking about if and else, then we'll save the for loops and while loops for the next video. So if and else is kind of like the very basic way to say yes or no, to tell the computer do something or don't. So if and else is broken up to look like this. If, so you literally type if, and then you're going to have in parenthesis a condition that can resolve to true or false, a single true or false. So this is important here. You already know about logical values. So what happens, the expression, so this word condition, this is an expression. This expression must resolve. The output of this expression, the code that happens in this expression, has to return a single logical value, an atomic logical vector of length 1. And it needs to either be true or it needs to be false. Okay. So right here, I am drawing a single one random normal variable. Okay, so I've got a random normal distribution, and I go and get one single random value, and that's this thing right here, whatever this x rand is. And then I have a condition, and I say, is this single value less than 0? Then I say, if this is true, so if this condition is true, Then I do the task. I resolve the expression, whatever the expression is, inside of these curly braces. So whatever this task is, I do this. Okay. So if this random number is less than 0, and it's a single random number, which means that this resolves to a single true or false value, then I'm going to say this value is negative, and I'm going to print that to the console. Else, so recall here, this is a single logical value. It can either be true or it can be false. It cannot be anything else. If this is true, so else, then you would do this condition, do some other different task, okay? So if this thing is less than 0, then you're going to print the character string, this value is negative. And the reason I'm saying print the character string is because that's what the expression is doing inside the curly braces. If you had typed this value is negative, it would literally just print the character string, this value is negative. Else, do this other task. Well, what is the other task? The other task is if you had just typed quotes, you're a winner, it would return a character string to you in the console saying you're a winner, okay? So we're saying that if the value is negative, if the value is less than 0, print this value is negative. Otherwise, print you are a winner. Now, you may thinking like, okay, why is he belaboring this point so much? Because this is the foundation of like 70% of computer code, realistically. If you can really understand the intricacies of if else statements, then you can understand at a fundamental level what your computer is doing at least half of the time. Okay. The other thing to think about, like versus if and else statements, and then there's the other things to think about is like the for loop and the while loop. But like if and else, just the ability to make decisions based on a condition, this is 50–60% of computer code. Like once you get down to what's happening under the hood, we're just checking to see, is this true or not? If this is true, do this one thing. If it's not true, do something else. And this is how a computer makes decisions. Okay. Technically speaking, this is kind of how your brain makes decisions too. Like, okay, I say, if I am hungry, then do something about it. So the do something about it sometimes is go get food. Sometimes it's have a conversation with yourself. Like, okay, well, am I fasting? All right, well, if I'm fasting, so I have another if statement. So if I'm hungry, so that's one if statement. Then I have the next if statement. Am I fasting? If I'm not fasting, do I have food in the house? So check yes or no. Do I have food to eat in the house? If that answer is no, then I say, well, then I need to cook something. So do I have ingredients to cook in the house? Like, so your brain goes through all of these if-else statements, thousands and thousands, if not millions of if billions, trillions of if-else statements every single day. And that's what your brain is doing. Your computer can do some things like that. It can't work as fast as the human brain, at least not yet. But this is what's happening. It's saying, okay, if one condition is true, do one thing. If that condition is not true, do something else. All right. So this is an if-else statement. Let's go through another example. So right here we're going to draw another new random number from the normal distribution. And so I say, okay, go give me another number. So random normal, one random normal has to be only one, and check, is this random normal less than 0? If true, then we're going to print, well, this value is negative. If not, we're going to print, you're a winner. Well, it printed, this value is negative. So therefore, whatever this random normal was, it was less than or equal to 0. Okay. And here's an exercise that I'm going to leave with you. You may know about the absolute value function in mathematics. The absolute value function says whatever number comes into the function, if it is positive, return that number. If it is negative, return the opposite of that number. So if the number that comes into the function is -18, then the function will return +18. If the function that comes into the number is +5, return +5. Okay, this is an if-else statement. All right, so I want you to write an if-else chain, so something like this. So specify a number, whatever the number is, and then write an if-else chain to turn that value to replicate the functionality of the absolute value function, and just do it as an if-else chain. Don't write it as a function just yet. All right, and next time we'll pick up with for loops. So see you soon.